Good afternoon, ladies and gentlemen, and thank you kindly for tuning in to the Rewind Electric Show, filmed here at the better edge of the Mojave Desert in southwest Utah. And it is a beautiful sunny day today. Depending on what weather report you watch, it could be 79 or 84 as the high, which would make it the hottest day of the year so far. I am not going to waste time. I'm going to try to work fast and talk slow. I have a tendency to do the opposite of both. If you saw my previous video, which was a service on this Deluxe Electric Mistress, then you'll know what we're in for today. Today I'm going to be running a similar operation on this Deluxe Memory Man, but we're going to go a little bit farther in that I know this has some capacitors which need some replacements. Now, if only I could find my bag of parts, which is certainly sitting right here somewhere. Okay, here we go. And I've got some capacitors there to use inside. Okay, let's get right to it. Now, how do I know that the capacitors in here need replacement? Is it just because they were installed in 1970 something? No, not just because. That does lend some weight to the theory that they are not necessarily in the best of conditions. However, there's more to it than that. I seem to be... Oh, here we go. My little bag of parts. I'm going to just keep the stuff in here as I go. I metered the caps last time I was in here. I don't remember if that was in a video or not. I think this is showing up in a video briefly in some capacity, but it was mostly just to demo it, perhaps. I don't know. However, I metered them and they read a bit high, and knowing these caps and knowing how they live and what they do before they die, I know that reading high is, it's not a sign of failure, but it is a common step with these caps when they are about to fail. I'm going to make a little adjustment here. Can you see that okay? Look at that. Look how close this wire is to this one. Just gonna give it a little room there. Did you see what I did? This is how EH stuff is, I'm learning. So I'm not the most, whoa, big zoom there. I'm not the most experienced guy when it comes to Electro-Harmonix stuff at all. I've generally not been too interested in it or impressed with it. That's just my limited experience. I have found a few pedals along the way of theirs, old ones that I liked quite a bit, and but mostly I didn't. Mostly I thought that they were too extreme. They're very, like, whatever they are, you know, very flangey, very phasey, very coursey, way more than I want. But recently, actually starting with this one right here, I've come to like them. Come to find that if you buy 3 or 4, there might be a gem in there, as this one is. So these two are the caps that I plan to replace. Now I'm going to take them out, but I'm also going to, I think, turn on the soldering iron. I'm going to test them on my Sprague TO2 to see, TO6A, and that's going to test them at the rated voltage or higher. I could go well up to the like 600 volt range if I wanted to pop one, but that's a proper capacitor tester for the sort of filter caps like you would find in this, or even amplifiers that run that high, where you can actually test them at operating voltage for leakage. You get one of those little meters. I mean, I've got nothing against Peak. I've got one of their meters here for transistors. But those meters, you know, what's running, they have what, like a triple A in them? What's running 1.5 volts through a 450 volt capacitor going to tell you about if it leaks or not? That it doesn't leak at 1.5 volts. Okay, who cares? Are you running it at 1.5 volts? No, you're running it at 450, 500, 600 volts. That's what matters. So there are other schools of thought on that. I am not the most qualified person at anything other than being me. I don't even know if I'm the most qualified person at being me. So yeah, you know, take that with a grain of salt. I need my duck. Hold on, please. Okay, let's get the duck fired up. I'll show you why I call him a duck. My son named him that. That's exactly why. And while that's heating up, I'm gonna take the liberty to empty out the reservoir of gross old solder. I probably should take the TO2 down and start warming that up as well. But kind of short for room on the bench today, so I'm not gonna. All right, let's get this cap out. This one first. Being honest, I'm just testing these caps to sort of show the process and to humor others. I really don't care how they test. I'm gonna change them anyway, and I am not at all the kind of guy to just shotgun change all the caps and something. That's definitely not me. I'm just familiar enough with these caps, and I know that this is my piece of equipment, and I know what I want out of it, that I'm just going to change them anyway. But I'm going to test them to show the process. And I'm not guaranteeing that they are or are not going to read anything. Oh boy, did I just... I think the pad might have just come loose off that one. It did. Okay. Should note where the... Well, negative is on the ground bus. To the right. Okay, there's one. No, it's really not the end of the world that that pad came loose. It's not great. But I can run the... There's still copper showing on the trace, and I can also run right to that leg of that resistor there. I guess I'll take them both out at once. Yeah, that one too. Not the world's greatest PCB quality is it? Okay, negative is, you know what's funny? Oh, positive is marked on this cap. Glad I noticed that. Is the other one like that? No. Man, that is weird. One cap is noted as negative, one cap is noted as positive. Okay. That is the world we live in. EH stuff is... Obviously, it can sound amazing, but... it's kind of junky inside, really. All right, should we... I just want to have a look at the traces on there and see how they are. Yeah, I think they're okay. All right, let's set this aside and test those caps. Actually, let me... While I've got the duct heated up, I'm going to desolder this power cord. Get that out of here. That is also happening. Slip. It's kind of precarious. Okay. This thing is like rotting and turning to dust. I'll just take this off while we're here. Turn the duct off. There we go. Okay, there we go. And we'll put a new power cord on there shortly. But this is gonna allow us to make some room on the bench. Okay, and we're gonna set this whole unit aside. Pull this guy down. Hello. This is one of my favorite pieces of test equipment. Dangerous. It is a dangerous piece of test equipment for certain. I mean, you're running 600 volts through those leads that you're playing around with. So we're going to be very careful. Use some high voltage probes from Fluke. We're going to operate with safety in mind. wonder, should I zoom out? Oh boy. Oh, that's as zoomed out as it's going to go, isn't it? Okay, plug this in. I could lay it on its back, I suppose. I don't know if that's ideal, but it'll work. Let's put this Mark Foley Stratocaster bridge right behind it. How's that? I think that's groovy. Okay. Let's take this off the 60 to 600 volt range because first cap we're going to test is 35 volts. So we'll go 6 to 60. Okay, the positive side is marked on this one. Let me show you that. Is that weird or what? See, that's the positive lead, and that was hooked up to the PCB on the side of the PCB that was marked as positive. Okay, so we're gonna hook that up to positive, hook this one up to negative, and I'm gonna put on my glasses just in case it pops, and we're gonna turn this on. Voltage is down to 0 on these really sweet backlight knobs. We are in discharge right now. I'm just going to let this warm up. Have a sip of my iced coffee in the meantime. We're supposed to talk about pickups, right? What about pickups? I need to buy a pickup. I sold my truck. I had a 2016, I forget, 2014 Ram 1500 with the 5.7 liter Hemi in it, and it was painted copper head pearl. That's the name of their factory color. I bought it used. I didn't pick that color, but it's a color that's used on the Jeep Rubicons, but I had only seen a different sort of orange color on the Rams, but that's the color mine was. And I liked the idea that I drove a copper pickup because I work on copper pickups. That was fun. But I need to so it had a lot of work done on it, suspension and such, and it needed some expensive work, so I took the opportunity to sell it rather than sink more money into it. It was geared towards off-roading, and I'm a family man. Not that I'm not doing any off-roading, but this is a pointless story. I'm considering a smaller pickup truck rather than a full-size, like a Tacoma or something, or a Ranger. But I'd like to find one that has a bigger engine in it, because I still want to put big off-road tires on it, because we I live out here in the desert, and we're often off-roading for not just recreation, just to get a place you want to be. Anyway, there's my pickup talk. This should be warmed up enough to test. Okay, so let's go to test. Oh, yeah, that wants to leak right away. Yeah. think even on the 60 setting it's going to go. Yeah. I mean, it should be 0. It shouldn't leak at all. If I'm going up to 60 volts, that's understandable that I'm exceeding its rating, but okay, so yeah. I'm going to discharge, unhook it. I don't know if you can see what I'm doing, but I'm going to manually short that capacitor. Do it this way. And done with that one. Okay, now this one is a 50 volt, 220 microfarad. Oops. Sorry. And this one is marked on the negative side. It's an L in the cap. I wonder if this is original. It says 77 on it. It is. Okay, so we start at 60. What was the voltage rating on this again? 50 volts. All right, so 6 to 60 is the right range. And let's go to test. Yep, this one's leaking too. Now we can see the voltage. It might be at about 50 volts. If we press this, it'll say, yeah, so factor of 10 there, 50 volts. But this cap is rated for, was it 50? Yeah, 50. It's the leakage is starting to go down, and that'll happen. But the fact that it's leaking, I don't like. Okay. And manually shorting that just in case. I mean, you know, I think that thing's doing its job, but should we pop a new capacitor on here to see what it does? Okay, so here's a new worth capacitor. And this is 220 microfarads at 160 volts, so it's the same capacitance rating that it's rated for higher voltage. Let's hook it up. See how this behaves. Down to 60, and we'll raise this up, and look, it doesn't budge. Look at that. That's what you want to see. Oh wait, I'm in discharge. Ha 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 ha. Watch me be wrong about this. Okay. Yeah. Only if I jump it. But that's also at 55 volts. Let's take this up to, okay, so we're at 60 volts, a little past 60 volts. The needle fluctuated a little bit, but that might just be that this is old. It dropped down. Let's do it again. Let's do a higher reading. This cap's rated for 160 volts. Let's take it there. Okay, this is, whoop, that was it. I'm a little past it. That says 150. I'm giving a little bit of leeway here. A little bit of safety net. Yeah, nothing. And we're discharging it, and we're turning that off. And we're unplugging it. So like I said, in the case of these, I knew that those capacitors were reading high in capacitance, which is a sign. It's not universally a sign of pending failure, but in the case of those, considering brand, age, application, where they were in the circuit, like that's my experience, and it's enough for me to say, get them gone. For me, you know, this isn't a piece that I'm restoring and, you know, returning to a customer or something I'm going to sell. This is a keeper piece that I'm going to use. But I wanted to show anyway how you can test caps at voltage. That'll also test, you can use it as a megger. It'll test insulation resistance. Okay. Now, do I want to use the Worth cap, or do I want to use something else? Got some Nichicons. What else did I get? I think this is also a Nichicon. And a Mallory. I'm going to use the two Worths, but I'm also going to pull these all out of here. I'm just pulling these out of their bulk packaging to be used, to be stored in my modern electrolytics area. Bin, that's the word I was looking for. Which I think is over there. Somewhere, over there somewhere. Yeah, I see it. All right. Free this bin up. This never feels right. I feel like those are on there too tight. Okay, bring this guy back over and do the little one first. 100, was that right? One moment. Yeah, 135 volts, and this is 100 at 100, perfect, and 220 at 50 volts, 220 once. Yeah, we're good. We're good. I'm gonna I will put these in the little parts gizmo doodad. They're absolutely trash. Not necessary to do that. Okay, positive on that side. Now we gotta deal with those broken pads. Let's see how this pans out. I hope this is visible, what I'm doing here. This is what I was trying to do. I should have just done it this way to begin with. And that gives a nice gentle bend in those legs. Okay, see how it's going to sit there nice and clean. Should put something under this. That'll just keep it from getting scratched up. Should have done that yesterday. I don't know if there's anything left of that pad. I'm gonna pin it to the adjacent connection right here where the trace flows to next. There we go. This iron's too hot. I think that one's okay, but we're going to do a little continuity test in a minute. Let me just get this one in first and we can do the same with both. Now this one was marked positive, so the negative is going to go over there. Okay, spacing looks good. Put a nice gentle bend in the leads as such. Okay, I'm going to do the same thing on this one where I join it to that adjacent resistor because these pads are so weak. I will try to put a little solder on this. I don't think there's anything left to solder to, honestly. But it'll give a little bit of support to the base of that lead. Yeah, there's nothing there. Okay, so we're going to solder right here. I'm going to come back and adjust that again. There, got a nice good one. Good connection on that one. Big pad there. Just nip the end of that off. Just so it doesn't poke anything or anybody. Try a little dab of paste flux. See if I can maybe get it to encourage a little bit of solder on that tiny bit of copper that's still remaining there on the trace. And there's not much. It's okay because it's over here. Solder there too. But I'd love to have a little blob of solder right there just to support that lead a bit, if it will. Yeah, that's enough, I guess. Take what we can get. Okay. All right. Gonna check continuity. To check capacitance to get continuity on that because it's a capacitor. It's going to block DC. And what do we read? $98. Perfect. It's supposed to be 100, wasn't it? Or was it 220? 220. Now it is in circuit. Let's see what we get right here. Oh, there we go. 219. Now what do I get here? That is not good. $219. Now this one, I'm not loving it. $100, 102 actually. Let's try the continuity. And $100. Okay, so it looks like it's all done correctly. I wouldn't go that far. It's all gonna work. Okay, one thing I wanted to do is clean this up a little bit. That's not coming out, but I'd like it if this did. So let's see if I can get that switch nut off without stripping it. And if it's like the other one, then it's gonna be iffy. Yeah, it's too small for that. It's loose enough. I hate to do this with these pliers. That's all it needed. Okay, and that's all just so I can clean this. Perhaps not the best thing to use isopropyl. But again, this is mine. And I'm just trying to get that grime around the knobs and around that switch and around these LEDs. Look at that. See, that's why it's not the best stuff to use. And that's it. That's all we're doing. There. Just a dry cloth, dry towel. Okay. Let's switch back in. The part I hate. I don't know if you can even see that. Perfect. Let's get this PCB back in. I want to find out what all those trim pots in the Deluxe electric mistress do. Not so worried about what they do in this one. They're all kind of like works or doesn't work sort of things in the delays. There might be one that's wet to dry balance, but I didn't have an issue with the wet to dry balance in this. So, but in that electric mistress, it's so intense for me. Like, the effect is very strong at all settings. I like it with all the knobs down. And I wonder if one of those pots in that one might be something to tame it a bit. That would be handy. I need to put a new power cord in and ground it. That's going to involve removing this transformer. Hopefully I don't need to take any of that other... I don't need to take that PCB back out again. I don't think I do. Just rough up the chassis a little bit where we're going to solder to it, which is right there. We're going to use one of these bolts on the power transformer as the location for our ground, but I am going to solder the ground to the chassis as well. And for that, we will need this mammoth jammer right here. Hopefully this is all staying in focus. Put a little scrap of wood under this just so I don't melt my really sweet Stumac foam pad thing. Okay. That's really all you need for that step is just a little tiny bit of solder on that chassis. We'll come back and use that in a minute to attach the ground. I'm going to put one of these transformer mounting screws back in to hold it in place. But I'm going to do it loosely. Actually, I can't because I'm going to put Loctite on it, so I can't have that sit for a while and then tighten it back up. We'll just go right onto the ground. Okay. Here's the cord we're going to use. It's a 3-prong IEC taken from a Electro-Harmonix LA2A compressor by Universal Audio these days, and has been for many years. I think Universal Audio put their name on the LA2A only a couple years after it was invented. It's not really like a reissue. They've always been making it. Okay. A little bit of talc on there. Talked about this yesterday. The order of operations, or the intended layout, maybe is a better way to put it, for power cords, is that you have your ground the longest, and then your neutral and your hot shorter, and your hot the shortest. These two need to land on that switch. I need to make sure that the ground's going to reach. No, I don't think it is. I need to strip a little more off. And that's because if you yank the cord out, the idea is that the hot breaks first before the neutral and the ground. And that if the neutral breaks, it breaks before the ground. And that way your ground is the last wire connected when the cord's getting yanked out, and your hot and your neutral are live and just bouncing around inside the chassis. And then if one of them hits ground, hopefully it'll trip your breaker and stop the flow of electrons. I guess you probably can't see what I'm doing. I'm just trying to strip this without nicking the insulation on any of the internal conductors. So it's kind of a chore, but it's the way to do it. Razor blade's a good tool for that too. And I think I'll employ that right now. Okay. All right. Okay, little ground lug. I don't like the plastic. It just kind of gets in the way. So that comes off. I like to both crimp and solder the lug. So my method is slip that wire through, turn it to the side a little bit, crimp it, okay, and then solder it down. Okay, so there you go. Crimped and soldered. All right, now we need a little wire crimpy grommet thing. I'm pretty sure that's the exactly professional correct term for it. This. And that will hold the wire where I put it in here. Okay, so we need it to basically just barely protrude through there. In fact, I think I have enough room that I can solder the 2 terminals onto the switch before I put that in. Yeah, that'll just leave me a little bit more room to solder without melting anything. Get this up out of the way. Now there's 3 terminals on the switch. 2 of them are connected to the power transformer. One of them is not. The one that is not is the one that's going to be switched on and off, and so that's where the hot's going to land. Let's see. And then the one on the other side that is always connected to the power transformer will be neutral. So that way we're switching the hot and not switching the neutral, because that's how you're supposed to do it. There's not a lot of room to work in here. Need my little hook tool. I'm just making sure the end of that copper wire is actually wrapped around the terminal. I'm not going to just pass it through a hole and tack it on. Solder's not glue. You want a mechanical bond. And the solder just reinforces that and creates an electrical connection, chemical connection. It's already electrically connected. Okay, this is tricky. not have a lot of room to work on. Okay. Making sure that's flowed solid. And it is. Okay, now we're gonna put the neutral in, and then we're done with all the hard stuff. So I'm going to try to poke a little hole in the existing solder with this to slip that neutral in. Okay. Just makes it easier than trying to do it while it's molten solder. Tin it a little bit, otherwise it's going to fray. But just a little, otherwise you build up volume and then you're going to have a little trouble getting it through. There we go. So close. Needs just a little more room. Just widening that hole a little bit. I hope you guys can see what's going on here. Whew. Just enlarging the hole, which is really just pushing some solder off to the side so that I can slip this through that hole in the switch lug. And I really hope that it'll do it. Oh, it's so close. Just a little more. Don't want to break that switch lug. It's very fragile. Okay, that's gotta be good. Yeah, all right. Okay, you just gotta get solder on there. And that is that switch, that full AC power on the neutral is very close to that little LED down there, so I'm going to bend these lugs up. Bend that one up a little too. As is the hot. Okay. Now we got those up out of the way. Okay. All right, man, we're making progress. We're getting close here. So now I just got to crimp this on and then put the ground on to the chassis. Bolt the transformer in. And we'll be all done. Okay, there we go. See, that's nice, neat, and clean. Hot's going to the hot side, neutral's going to the neutral side. Lots of slack there for the ground. And this is going to go right here. All right, this is the tool you need to put that on, and this makes it so easy, so you don't have to drill oversized holes and use twist ties and end up with a compromised connection. You just give that a little squeeze, and you push it in. That's it. There we go. And that's not going anywhere. Lead address. Okay, now we just got to get the transformer mounted, solder this as well as physically connect it, and we'll be all set. There's a little bit of crustiness from that transformer, some varnish or whatever it was potted in. Okay, time for a drop of thread locker on the threads. If you haven't heard my thread locker rant, I don't like that blue Loctite comes in a red tube. And red Loctite, well, I don't know, does it come in a blue tube? Boy, I don't remember. That would be awful. That would be almost as awful as me firing this up in a few minutes and having it not working, which is a distinct possibility. Okay. Oh no. All right. I gotta fish that. That went in the trash. I gotta go find that nut. I saw it go right down the side of my nearly full trash bag. Hate that. Let me see if I can find it. Oh, these might be too big. Yep. I might be going fishing. Getting that trash can. All right. Extension tool with a magnet on it. That's what we gotta do. See you in a minute. No big deal. Just a little digging in the trash. There's those metal bread ties from yesterday's project. Oh yeah, and the 9-volt battery clip from the Japanese Arion delay. It's like a tour of history. The history of my trash. Oh, I thought I saw it, but that was a 9-volt battery. Snap. Okay, we're nearly to the bottom. Just going through everything one piece at a time because I dug to the bottom. Got down to the little dusty bits and it wasn't there, so I must have pulled it out. Saw it go in. Oh, got it. Oh my gosh. I got it. I was getting concerned. Look at that though. There it is. Okay. Gee. All right. Let's not do that again. Now we're going through the chassis, through the ground lug, and then through the transformer. At least that's the plan. All right, I'm gonna drop a Loctite. Now let's try to lose it this time. All right, and then you need to solder to that. I'm gonna try and use this guy. Watch how fast this heats up. Okay, there we go. It's already 450 at the tip. Scrap wood. Perfect. This thing's days are numbered. That little iron that I just used to solder that steel chassis ground. There's that aluminum. Steel. Beautiful. Okay. Can you see it? There's our ground lug. It is soldered to both the round eyelet lug and then screwed on to that transformer mounting bolt and The whole assembly there is soldered to the chassis. Okay, there's our ground wire, just sitting there with plenty of slack. Okay, let's put it back together. I think that's it. Okay, where's the back of the case? Here we go. Of course, it's missing feet because it is an Electro-Harmonix product, and they all are always missing feet. This should probably go over here. Keep all that AC stuff together and away from the signal voltages. I want to make sure these jacks are clear and there's nothing that's going to get caught on any plugs coming in. Yeah, we're good. Okay. Okay, so we've got this back together now. Gotta put the knobs on. Kind of weird how they arrange those. You can't really rotate the pots at all to change where the minimum and maximum is, but there's a, like, the silk screening doesn't really match up. But I guess that's just part of the charm. Okay, so I'm gonna fire this up on the Variac just to make sure I don't let the smoke out, since we did mess with the power supply quite a bit. Okay, power. I don't know if this is on or off. I don't remember. I think it should be on. I'm just gonna bring it up slow. Watch the current draw. Okay, 20 volts. And I see the LEDs coming on. Good sign. 30 volts, 0.01 amps at 40 volts. So I think we're doing good. 50 volts, still 0.01. 60 volts, 0.01. LEDs going. 75 volts. And I see the overload. That's interesting. It's oscillating. Okay, yeah, it's working. So I'm gonna plug this in over here. And put the Princeton reverb back on the Variac. The old benchtop 1978 Princeton reverb, of course. And we're going to do something fun with that in a minute. But for now, I'm just going to take this amp up to about, let's say, 113.4. Seems like a good place to be. By the way, this has nothing at all to do with this video, but I just wanted to quickly tease something here. Little alien ship passing by there. That's gonna be fun for another one.